Hello and welcome to How to Use Minitab to Calculate Probabilities on the Normal Distribution. Today's example will be looking at a stretch of I-10 that has approximately normal distribution for the speed of vehicles traveling along that. I just sort of read the first question. So assuming speeds of vehicles along a stretch of I-10 are approximately normally distributed with a mean of 71 miles per hour and a standard deviation of 8 miles per hour, we're going to answer the following probability questions. So we want to know what's the probability that the current speed of the car, and I'm going to use x for representing the car's speed, so is less than or equal to the speed limit, so under 65 miles per hour or equal to it. So let's insert less than or equal to 65, and I'm going to include the miles per hour in here. All right, so I'm going to go to the graph probability distribution plot and then choose view probability and hit OK. You'll notice that the default for the probability distribution plot menu is the normal distribution. The reason it is this is because, well, the normal distribution gets used more than anything else, and it's set to be the standard normal with mean 0 and standard deviation 1. We have a normal distribution, but our mean is actually 71 miles per hour and our standard deviation is actually 8 miles per hour. Okay, let's go ahead and hit the shaded area tab. Now, in particular, I'm looking for less than 65 miles per hour, so I'm going to want a left tail, but you have, I almost made a mistake. I'm not interested in inputting the probability. I want to know the probability. I have to input the x value. So since I know the value and I want to know the probability, I need to tell it what I'm inputting. So I'm going to input this, and I want a left tail just like we discussed, and I'm looking at 65. There we go. I'm going to go ahead and hit OK. We should be good to go. Okay, so it's 0.2266. So that's my proportion that is going less than 65 miles per hour. Now we're asked what proportion of vehicles will be going less than 50 miles per hour. So I want to know the probability that a vehicle is going less than 50 miles per hour. So I'm going to go back. Okay, so I'm going to go back to graph probability distribution plot and then select view probability, hit OK. I'm still on the same distribution, same mean, same standard deviation. The only thing different is I'm looking at a different probability, so I'm going to be selecting shaded area. I'm still doing a left tail, and I'm going to put in 50, and then I'm going to hit OK. And some of you are squirming in your pants, or whatever else, your pajamas. I don't know what you do in your spare time. Wondering why on earth is she doing the exact same thing for a less than as a less than or equal to? Well, here's a food for thought. I'm going to go back to the other graph. Hold on. Window, distribution plot number 4. Okay, there we are. So one of the things to keep in mind is we are doing probability by area. Okay. X being equal to 65 is just the line at 65. So the height here and the line above just 65. So it has no width. So it actually has no area when you have an equal to. So whether or not it's an equal to or not equal to doesn't make a difference in your probability. It's only the less than that's creating it. So for a continuous distribution, since there isn't since you can have any infinite values in between, whether or not something is an equal to makes no difference in how you calculate the probability, unlike the discrete distributions, the geometric and the binomial. Okay, so let's move on and go to what's the probability that the proportion of vehicles would be going more than 80 miles per hour. So I want to know if it's bigger than 80. And again, this being greater than 80 would be the same thing as greater than or equal to, because there is no area on a line. Lines are infinitely thin. And we do probability by area. So back to graph, probability distribution plot, view probability, still doing the same thing. And I want to do shaded area, but now I'm doing a greater than, so I want a right tail, and I want it to be 80 miles per hour. So again, I'm doing greater than as a right tail because if I'm looking at things that are greater than 80, that's to the stuff that lies to the right of 80, and hence a right tail. Let's hit OK. And there we are. Let's record that value, 0.1303. Alrighty. And now we have a slightly different question. A researcher wants to know what values make up the central middle 80% of speeds. What is the range of speeds what range of speeds is this? Sorry. So this is a little bit of a weird question because it's not asking you for a probability, it's asking you for a speed, a score. So I don't know the x. I'm just going to leave blanks here. These are unknown. But I do know I want it to be a middle so that I get 80% here. And how you do this on Minitab is you'd go back to Graph, Probability Distribution Plot, View Probability, hit OK, and then click on Shaded Area, still the same distribution. Now, previously we've had x's and wanted to know probabilities, so we've selected x value. Define shaded area by the x value. Here, we know the area, but we don't know the x value. So I want to define it by probability. So I'm going to change the radial button to probability. And when I do that, nothing really changes except for this little box down below shows up as probability. So I have a couple different ways I could do this. I want the middle 80%. So if you're trying to picture what this looks like, here's the center of my distribution, and I want to figure out whatever this value is and this value is, so that in the middle here is 80%. So if the middle is 80% and this is perfectly symmetric, so better than my drawing, these two tails together make 20% because it must all add up to 100, and therefore just one tail would be 10%. So as you look at this, as you look at the options of right tail, left tail, both tail, there are several ways you could do this. If you wanted to do right tail, you could do right tail with 10% because that's just one tail to get the upper value. You could then do it again with left tail to get the lower value by entering it in 10%. Or you could do both tails and enter in 20% because you want 20% to make each of the tails together. Or you can do middle, which is the one I kind of like. So I'm going to do, let's do both these. So we'll do both tails, and I want 20% amongst the tails. So this is, you got to be careful because this is a percent and this says probability, which is a decimal. You don't want to put a 20 in there. Go ahead and put OK. And it gives you the two values. So it looks to be between 60.75 and 81.25. Okay. The other way you could do this is, I'm going to go back through the exact same steps. So graph, probability distribution plot, view probability, hit OK. I'm going to go back to shaded area. You could also do it as a middle, in which case you're going to want to know what probability is on the left and what's on the right. So for me, it's 10% in each. So you could do 0.10, 0.10, and hit OK. And it'll come out exactly the same. Ta-da! And I like this one a little bit better because notice it shades the one I actually want, the 80% in the middle, and that's another quick check to make sure that you actually have the right one because it shades the correct area. You know, as long as you keep in mind that when you're using the other win graph, this is your stuff that's the complement, the stuff you don't want. Anyway, you get the idea. Cool. All right, last question. If you're picturing this, let me draw your distribution real quick. Center is 71 miles per hour. And I want this so that whatever score this is, I don't know it, the area above it is 10% or 0.10. So the upper area, 10%. That's the idea behind what we're looking for. So if we were to write that as a probability statement, we would write the probability that whatever this is, so I'm putting a question mark for my unknown, then I look at the score is greater than it, then I get the upper 10%. Oops, get equal sign. Cool. So as you notice, a couple things here. Clearly this is a right tail. It should be something above 71 miles per hour. And the area that I want it to make is 10%. So we're going to go back to graph, down to probability distribution plot, view probability, same distribution, shaded area. And now I want a right tail, and I notice that from the description what's happening here, the upper 10%, and how I've drawn my probability statement, and I want that to be upper 10%, so this is already set to be 10%, so I'm good. Let's go ahead and hit OK. And there she is. So those traveling above, and I'm going to say above 81 miles per hour. I am rounding here. which is an unusual speed limit. So they probably aren't going to do that. They might do like 80, which case they'd get a couple more people. And I've rounded down too, so it would be more than 10%, more than likely. So if they wanted to be exact, which I highly doubt any court in the country is going to choose 81.25 miles per hour as their correct. So I don't like how this isn't a sentence. Speeds above 81.25 miles per hour. So that's it. Hope you enjoyed this Minitab lesson, and good luck on your assignment.